In a lot of problems in the future, it will be necessary to know whether the sample came from a normal population or not. Next, we will discuss how does one know whether the population is normal or not based on a sample. We intuitively expect that the shape of the distribution of a sample is approximately the same as the shape of the population distribution. So if one can obtain a large representative sample, or the census, then the shape of its histogram will resemble the shape of the population's distribution. Therefore, if the distribution looks normal, then it is an indicator that the sample came from a normal population. But what do we do when only a small sample can be obtained? In such case, we will use a graph called a normality plot. Turns out that normal populations are so common and well studied that we almost know what to expect from a sample of any small size. The expectations are formulated in the following table. This table provides the expected z-scores from a sample of each size from 5 to 22 in ascending order. So if we have a sample of size 5, then we expect that one of the observations will be 1.18 standard deviations below the mean, one of the observations will be 0.5 standard deviations below the mean, one of the observations will be equal the mean, one of the observations will be 0.5 standard deviations above the mean, and one of the observations will be 1.18 standard deviations above the mean. To construct a normality plot, we first sort the sample of size n in ascending order. Then, in the table of expected z-scores, we find the column corresponding to the sample size n. Then, we list the expected z-scores from the table side by side with the observations from the sample. Then, we construct the scatter plot with expected z-scores as the input and the data as the output. If the normality plot has a roughly linear pattern, you can assume that the sample came from a normally distributed population. However, if the normality plot doesn't have a roughly linear pattern, you cannot assume that the sample is from a normal population. These guidelines should be interpreted loosely for smaller samples, but usually strictly for larger samples. For example, a sample of 5 Uber drivers were asked how many hours they worked last week, and the following answers were obtained from the sample. Let's use the normality plot to determine whether the population of weekly driving time is normally distributed for Uber drivers. First, we have to sort the sample of size 5 in ascending order. Then, in the table of expected z-scores, we find the column corresponding to the sample size 5. Then, we list the expected z-scores side by side with the observations in the sample. Now, we construct the scatter plot by plotting the points one by one. This scatter plot is called the normality plot. Now, we look at the pattern, and in this case, the pattern is clearly linear. Therefore, we can assume that the population of weekly driving times for Uber drivers has a normal distribution. Let's consider another example. A simple random sample of 12 tax returns from last year revealed the following adjusted gross incomes in thousands of dollars that are shown in the table. Let's construct the normality plot for the data and use it to assess the normality of the population of adjusted gross incomes. Since the plot doesn't look linear and actually has a distinct nonlinear pattern, we can conclude that the population of adjusted gross incomes is not normally distributed. When technology isn't available, to assess the normality, just look at any visual representation of the sample, such as dot plot, box plot, or stem and leaf, and check the shape of the distribution for asymmetry, modality, and the outliers.